What's going on, guys? Welcome back to this video. Today we're going to talk about hacking the blockchain. So basically, this is a very huge subject. And before we start talking about hacking the blockchain and what do I mean by hacking the blockchain, first we're going to have to understand what is the blockchain, how it's composed, what are the smart contracts, and what are the types of the blockchain, how the blockchain is secured. Now, basically, when we talk about hacking the blockchain, we don't mean hacking it in the traditional sense of hacking, where a hacker inserts a malicious code into a computer program or a web program and then controls its logic or how it works. It doesn't mean getting access to a specific OS. That's not how it works. There is a different mechanism on how blockchain can be hacked. Take a look at this. You see, blockchain starts from here. This is the base, okay? And then we have the blocks. So the blocks comes here. Now, basically what happens, all transactions performed on the blockchain are performed on these blocks. That's why the blockchain is called the blockchain, because it's divided into blocks where transactions take place. Then you got the nodes. The nodes are the network of computers that verify the transactions. So we see every block there are transactions. These transactions are verified using the nodes. So these are the network of computers verifying the blocks. Okay. And next we have the smart contracts. That's the important subject if you want to understand how blockchain or how contracts are hacked in blockchain. So basically the smart contracts are programs executed on the blockchain. So we have basically block A, and block A has a couple of contracts. These contracts they self-execute basically when a certain condition is met. And through the smart contracts, we interact with the blockchain and perform transactions. So now if we want to send a transaction to the blockchain, we send it through the smart contracts. And then the transaction can be used, such as maybe to add data to the block, maybe to modify data, maybe to delete data. All this done by interacting with the smart contracts, thus meaning we are performing a transaction on the blockchain. Now, an example of a blockchain is the Ethereum. Ethereum is a type of blockchain, as all of you know. And in this video, we're going to see how that the Ethereum blockchain uses JSON-RPC calls to handle the client requests or handle the client transactions. And basically, it sends the response to the client using JSON and uses RPC calls. And we'll see that if you want to use the blockchain, specifically the Ethereum blockchain, you're going to have to work with the Ethereum client that listens on port 8545. Now, this is actually early. We're going to talk about this when we take the example on how to exploit vulnerabilities in Ethereum blockchain. But for now, that's how it works. Cryptography, along with something called the consensus mechanics, are used together to encrypt the data in the blockchain. So when someone signs a transaction or sends a transaction, the transaction gets encrypted using the available cryptographic techniques. Therefore, the transactions remain secured and encrypted, thus maintaining the integrity and privacy of the data. Now remember that the blockchain is a public ledger at the end, but the data is encrypted. Additional aspect of blockchain security is the consensus mechanics, which ensures the agreement between the parties doing the transaction and to prevent the fraud. As you can see, lastly, the encrypted data links blocks to enhance the overall security. Now, since we mentioned that blockchain cannot be hacked in the traditional sense when hacking a computer program or a web application, a blockchain can be hacked when an attacker can take over its computational resources. We call this the hash rate. So the hash rate, it's the speed at which the transactions and the hashes are generated or performed on the blockchain. When an attacker can control majority of the resources on the blockchain, the computational power, they can control its hash rate. And when they can control its hash rate, they can maybe sign transactions or confirm transactions that they were not previously confirmed before. We call this 51% attack. Take a look at this. You see, this is the 51% attack where an attacker at least needs to control 50% or more than 50% of the computational power of the blockchain. Then, once they do that, they will be able to control the hash rate, the speed at which the transactions are performed, and thus they will be able to control the entire blockchain. Therefore, this allows them, as I mentioned earlier, to confirm transactions that they were not confirmed previously, or maybe sign transactions. Now, imagine you sent one Bitcoin to a friend, and it happened that that transaction was not confirmed several times on the blockchain. It was only confirmed one time. If it happened, an attacker modified the resources on the blockchain and controlled more than 50%, they will be able to spot that transaction, sending a Bitcoin to your friend, and then maybe confirm it or reverse it, sending the Bitcoin rerouted back to their wallet and maybe to another wallet. Now, before we start, I want you guys to be familiar with the Solidity language, which is the language used to build applications on the blockchain, mainly the smart contracts. In order to interact with the smart contracts and understand the source code of the a program that makes a smart contract, it's important to understand the syntax written in the code. So basically, Solidity language can help you achieve just that, and of course, much more. And this is the documentation. Now, don't forget also to check out the CAS tool, which is part of the Foundry book or the Foundry suite of tools, Forge, Chisel, and Anvil. What you need is the CAS tool, which is the tool used to interact with Ethereum applications. I want you guys also to check out the video where I used CAS to solve the Try Hack Me Hack Infinity challenge. You can see many examples of using the CAS tool to interact with the blockchain, update addresses, retrieve transactions, sending transactions. Don't forget to check this out. I'm going to put the link of this video in the video description. Websites and databases sometimes use the blockchain. For example, in my case here, this is a chat application or chatbot, the database of which uses the blockchain to store the conversations. Now, in this case, before doing any enumeration, adding, deleting, and sending data using the CAS tool that we shown earlier, before doing any of this, it's beneficial to retrieve the original name of the contracts. Okay, so the name of the contracts can be retrieved actually by first learning a couple of things. The first thing is the URL of the website that uses the blockchain. In my case here, it is known. Next, we want a cookie, the cookie or the token that is used to identify the users. Of course, that's if the website requires you to log in or to register in order to navigate or use its features. Sometimes it doesn't require you, so you don't have to specify the token. So cur-s, and that's the complete command. But first I have to modify a couple of things. So you see here -s specify the URL. That's the URL of the site that uses the blockchain. And then -p we specify the token. In my case here, the website requires me to log in to enjoy its full functionality. So you're gonna have to log in, and then when you log in, you are given the token or the cookie. So that's the token or the cookie that you can retrieve by going to inspect application, and you can find the token here or the cookie. It comes under different names. Okay, next I'm gonna have to modify the token first. Let's see here. It's the same token. Okay, I'm gonna leave this as is. And next, the JQ-R database. This is the name of the contract. In my case, the name of the contracts are given here if you click on this button. However, sometimes they are not known, so you have to find a way to learn the contract names. And then I send the output of the command to the file database.sol, Solidity language. When you execute this, you will be able to view the contents of the contract. Now, in my case, it's in the database file. You can do the same for the other contract or for other contracts that you know their names. So in my case here, I have two contracts that I retrieved, DB and chat. Have a look at the first one. Now, why viewing the contracts is important because some vulnerabilities may exist in the way the contract works, or it may reveal plain text information. Hard-coded credentials. By looking for these two, you'll be able to hack the entire blockchain. So let's have a look at this. Here we have the contract. As you can see, it defines database where it governs the users. So as you can see, we have password, role, and whether the user exists. So the main contract is database. And if you scroll down, we see other functions that checks on the users. This one is for registering the account, set the chat address, delete account, update password. Using the same logic we followed earlier when we exploited the application or the source code that controls the Ethereum balance, and we transform the full balance to our wallet, we can do the same here. But here the application doesn't contain any notable vulnerabilities or errors in the logic, and it doesn't contain any hard-coded credentials. Let's have a look at the next one, chat. first thing we note is the contract. This is the contract name, chat. And here we have the message, struct, we have content, the sender, and the timestamp. So it governs the conversations exchanged between the senders and the recipients. So we have the content of the message, the sender, and timestamp. Again, we follow the same process. We're gonna have to take a look at the functions and see how they work. So we have only owner. This function checks whether it's modifier actually. It checks whether the sender is the owner. If they're not, it's going to print only owner can call this function. So our mission here, or a goal, is to find a function or a modifier that has a vulnerability or an error in the way it operates and exploit that weakness. That's how we do it. Just like the way we did it with the while exploiting the source code in the Try Hack Me Hack Finity challenge, we were able to modify a certain function and transform the full balance from the treasury into our account. But for this contract, on the other contract, the functions does not contain any notable vulnerability that we can take advantage of. We still can play with these functions and maybe change how the application works and operates, but it's not our objective here. We want to dump most of the time we want to dump data from the blockchain. Now, it's not necessary when you download the contracts, it's not necessary you find a vulnerability or to find a hard-coded credential, but it's still part of the process to enumerate the contracts. One of the methods web applications interact with the blockchain is by using the Ethereum blockchain, and it uses the JSON-RPC API. And when you set this up with the application, it's going to listen on port 8545. So TCP port 8545 is used for the implementation of Ethereum blockchain to interact with your application or software application. So here, in order for a software application to interact with the Ethereum blockchain, either by reading blockchain data or by sending transactions to the network, it must connect to an Ethereum node. For this purpose, every Ethereum client implements a JSON-RPC specification. Understanding this is very important during the penetration testing process of any website-based, blockchain-based website or application. The application I am enumerating here uses this method to interact with the blockchain. For example, here in the Perp Suite history of the requests, we can see this URL. Let me scroll up and see this one. You see, this request is made to API JSON-RPC, which means that the site uses the Ethereum blockchain. If you go back to specifications here, we see for this purpose, every Ethereum client implements a JSON-RPC specification. Okay, so now knowing this, we now know that the application here uses JSON-RPC to operate on the blockchain. So now, having learned what is the blockchain used by the application, next we want to know how to talk to this blockchain, how to retrieve data, how to send or modify data. Now, since we have learned that it is using Ethereum JSON-RPC, next we want to see a documentation for how to work with this. Now, here in Quick Note, you'll be able to see the functions you can use with Ethereum RPC. Okay, let's see here, Ethereum JSON-RPC API, expand this, and we can see the accounts or the functions that can be used to interact with this type of blockchain. For example, Ethereum accounts RPC method returns an array of addresses owned by the client. So to retrieve the accounts, you can run this cur command. Remember that we use cur at the very first to retrieve the contracts. Here we do the same, we specify the URL. The method here is post, and here the content type is specified as JSON, and then the data is passed. Here in the method, we specify the function, Ethereum accounts, and any parameters required here, such as the ID and the version of the JSON-RPC. If you go back to the example here, you see there is a request to JSON-RPC. Now I want to find out how we can implement this to retrieve data from this website. Here we see another request, and now this request contains some methods or blockchain methods. So here the blockchain method is Ethernet balance to retrieve maybe the balance of the account, and here we have this one. This could be the address of the contract. if we take a look at the previous request, we can see the previous request is sent to API/chat_address, and upon sending the request, we saw that it returned an address. This could be the address of the chat operated by the site. Now, if we go back or go one more time here, we see the address of the chat is used in the request. Let's have a look at the get balance in the list of the methods here. So get balance returns the balance of given account address. So the parameters here, or they must be given parameters, is the address of the account that we want to retrieve the balance for. Okay, now let's have a look at this, send this to the repeater, and then we can freely play with it. So if we execute this, we can see that's the response, ID 1, JSON-RPC, and that's the result. Okay, now if we go back and maybe try another method, get accounts, of course the parameters will be different. So this method does not accept any parameters, so we're gonna have to remove the chat address, maybe keep latest. Yeah, we can remove the latest as well. Okay. You see, that's the response. It means we have this account. We have one account. And that's how now you can retrieve data from the blockchain. Okay, now since we have an account, let's go back and have a look at other methods. So we have get account. Retrieve account details by specifying an address and a block number. So let's have a look at the parameters. The account address for which the information is to be retrieved. Looks like we have an account address here. And the block reference, the block number in either hexadecimal or integer format. Available tags include latest for the latest mined block, pending for the pending state transactions, save or finalized to indicate different degrees of block information. Let's use the latest here. So now we go back, and here we're going to add two parameters. Okay, the first one is the address. We have the address and the latest. Okay, gonna copy this, and we have latest. Okay, and then we have the function name or the method name. Method not found. Let's try it with the chat address we found earlier. So go back to the proxy, and we remember the chat address. Let's see if it will work with this one. Still method not found. That's fine. Let's now go back and try other methods. Get block by hash, get block by number. So in get block by number returns the information of the block matching the given block number. So you know that blockchains, or the blockchain, is composed of blocks, right? Now these blocks have numbers. Here we retrieve information from the block by specifying its number. Okay, this one looks promising. The parameters required are the block number and the transaction detail flag. So now we modify the method name, and here I'm going to use latest to retrieve the latest block, and then we're going to specify the transaction detail flag. We're going to say it is true. Okay, looks like we have some data here. So these are the information stored, but in which block? Let's see the block number, if there's an indication of the block number. Transactions, input. Maybe that's the input sent by the user to interact with the chain or the application. But still we don't see any number for the block. Hash, minor number. That's the block number. Okay. It is written in hexadecimal. Now we can fine-tune the request actually to retrieve data from other blocks. So instead of latest, we can play with this and say 0x maybe 3 from the third block, and now we can see information retrieved from the third block. That's the block number, and this way we can then retrieve data from other blocks. let's start with one. You see here the input changes every time between blocks. Now this is the input written in hexadecimal. You can also decode this from hex and have a look at the the ASCII content. You can use CyberChef for this. So from hex, and that is in binary format. But there are some ASCII characters. You see, username already exists. We catch this here. We can see some data that's readable by the human eye. And we can see username Kira, and this could be a password. Let's look at other blocks too. And we take a look at the input. Let's have a look at the input of this one. Index range, index out of bounds. Now still I don't know how to make use of this. This is in binary. Probably if you remove the null bytes, it's going to make more sense. But here you are just dumping data off the blockchain. Still you can use the solidity language or the cast command to interact or to fine tune your interaction with this blockchain. But remember that you need things such as the private key and the target address. Now if you go back here, the address target here can be the chat address that we saw earlier, this one, or it can be the account that we retrieved from previous attempts. Go back to repeater, and remember that we used the get accounts. Okay, that also can be used here in the cast command. So that was it. I was able to cover this much in this video. Of course, I will be trying to cover much more about blockchain penetration testing in the upcoming videos. Stay safe, and I will see you later.